5, and we will discuss multimeters or metering systems for electrical components in this chapter. As I said before, if you know how to use a multimeter properly, probably this will cut down your job effort by half. And we'll talk about how they work, what kind of meters do we have in the field, how do we use them, the proper way to use them, and how do we read whatever information we have on the meter. And we'll do some examples. What are the differences? So we'll spend plenty of time in that, and I have an entire lab about using multimeters. So we'll talk about the use of volt ohm meter. It's usually a multimeter without the clip-on. So the volt ohm meter will measure the voltage and the resistance. We talk about the clamp ohm meter, which uses the clamp and electromagnetic field to measure the amperage. What does that mean to us? How do we get that reading? And how do we set the meter on the right setting? So when we did the lab, the first 2 labs with the wiring, you notice that you try to measure the voltage, but if you set your multimeter on resistance, it's not going to give you the right reading. So you have to set your resistance first and then get the proper reading. Explain the operation of all analog and electric and digital meters. Well, in the past we had analog meters, which they have a needle, goes back and forth. These, I think, are obsolete. Nobody uses them anymore. Most meters now, they have numbers. And we'll talk also about accuracy, how accurate they are. And most multimeters, they give you good accuracy now. How analog meters work. The operation of analog meter. By analog, they mean the one with the needle. I have some in the shop just to show what it looks like. Again, what are the advantages and disadvantages. I haven't seen anybody in the field now with analog meters, so, but in case you come across one of those, you'll know how they work. I spent too much time in the book talking about analog, and you bear in mind this book has been around for 20 years, so by that time, analog was very common. We'll talk about the digital one, and what is the accuracy, plus and minus. So if I get 118.7, what is my accuracy? And the accuracy, they give you a range for all digital meters, but each little meter have different accuracy. If you're going to work with very small voltage and small amperage, probably you need something that's very, very accurate to give you the right range. Describe the condition of resistance that can exist in an electric circuit in reference to continuity. So when we did last week, when we tested for a fuse, I asked you to test a fuse. What do we do? You remember? We all did it.
Put it on both ends.
You put it on both ends and you put it on resistance. If you have resistance, that means it's connected. No resistance, 0, that means it's broken. There's also something called continuity, which most multimeter will be if the wire is continuous. So this is the continuity and also the resistance. The source of energy, how does it work? Probably most of them are battery operated, and some of them have different resistances. So again, some meters, they have ranges, which probably you notice that a little bit that they have range. They give you, this range will be from 0 to 2 amps. From 2 to 20 amps, you put in that setting. And the reason being is they have a resistance. They have set of resistances inside the meter. And if you set in the wrong one, probably it will either cut out and give you no reading, or it will burn. So the cheap multimeter for $5 or so, they don't have any protective measures. So if you put it in the wrong setting, boom, it's gone. If you put it in DC and put it in AC, probably it will be burnt. So that's why you spend a little bit more on something that will be more reliable and will be able to handle your mistakes a little bit. Yeah.
It was like yesterday. I was like on my phone. I was like looking at like a voltmeter. It was like $700 or something like that.
Yeah, there are some very expensive.
But why? Like if it's the same thing, like what's it?
No, it's not the same thing. Probably it has more accuracy and it has more settings. And again, if you work with electronics and you measure it very small millivolts, you need something very accurate. And that depends on the electronics inside. And probably they have a lot of sub-circuit that will protect your multimeter even if you put it in the wrong location. Back in the days, they had a fuse. If you do something wrong, you blow up the fuse and you have to go change the fuse. Now, a lot of them, they do not have fuses. I'll bring two multimeters so we can. Okay? These are some of the common terms you'll hear when we talk about multimeter. It's an ammeter. It will measure amperage. Analog meter has the needle, and it uses also magnetic field. Clamp meter. This is a clamp meter. And are we familiar in how do we measure amperage? You guys are very smart and doing very well so far. I was very impressed. But you clamp one on one of the, either the hot or the neutral around it, and you set it on the amperage, and you should be able to get a reading. Continuity, it's a term used to check that the circuit is continuous and completely connected. Otherwise, it's not continuous. It will give you either open or short circuit. Digital. Digital comes from digits. It means it will show you numbers in it. That's digital. Analog will have a needle, and I'll show you one actually in the lab, see what it looks like. So when you say digital, this is a digital meter. It shows digits, shows numbers. Magnetic field. So we saw that really long video, and we saw that every wire has a magnetic field going around it, and that's what we measure. And that magnetic field can get really strong if it's a lot of voltage. So high voltage will draw very big magnetic field. So you have to be aware of that. Why? If you see a power line, you don't want to get too close to it. Probably it will have some kind of magnetic field, and probably it's dangerous. So even small wire at 0.025 amps, you can feel the magnetic field around that wire. Measurable resistance. There are some measurable resistance, some of them don't even show, they are very small. So the measurable resistance, how many ohms is going through one wire, and how many ohms are going through each component. We double check that for many reasons. Why do we need that in the field? In case you have to put the AC around 100 yards away from the house, there's no place to put it in the roof, you put it in the first floor and you have to go all the way up to the third floor. Or maybe the control panel is in the basement and you have to go all the way up to the first floor. You have to measure the resistance of the wire before you, but per foot. Either you measure it or sometimes it's labeled on the wire. And why do we do that? Because if we are going to run this long wire, we're gonna lose some voltage. Is the voltage at the component enough to turn it on or not? Usually they give you some ACs and some components, they can give you plus or minus, how much less and how much more we can go before the equipment stops to run. So we measure the resistance and we want to know the voltage drop. This could be a problem sometimes, and especially as the wires get older sometimes, or like if you have strange wire that has been chewed up and you lose some of the connection and the connectivity, you might lose some power and you might not be able to turn the equipment. And that's why we care about the measurable resistance. Also, when you try to test a transformer, some transformer will tell you how much resistance you're supposed to expect. Otherwise, it might not turn. And I will do that right now so you can, I'll do it in the document camera so you can see how it works. So that's measurable resistance. Ohmmeter, it measures the resistance. Open. With open you'll see 0, it's an open circuit, there's no connection at all. Short, there is connection, but it's not the right connection. So probably you're measuring something that's not what you're supposed to measure. Voltmeter measures voltage, and I'll show you how to measure voltage. So when you measure voltage, you're basically completing a circuit, and you're running your voltage coming from the wall through a resistance here in the multimeter, and you're measuring the voltage.
That's what completes the circuit, right?
Yeah, that's complete the circuit. So what happens is, you can go from hot to neutral. You can't just put it on the hot. You have to complete the circuit. Hot and neutral, and you get a reading. What else can you do besides hot and neutral? What else will complete the circuit?
Hot and hot.
No,
Oh.
hot and hot you'll get 220 at my spark. Hot and ground. So you can use hot and ground. So you see some electrician, they put it in the hot and they go to the casing. In the car, what is your ground?
When you cut it out, when the
Big
battery
flame.
out.
Yeah, your car is big enough to be ground for 12 volts. So any metal in the car is your ground. So if you don't complete the circuit, you don't get the ground. So that's how you measure voltage.
That's your question.
Can you measure voltage with equipment that does not have a battery? This thing has a battery in it. Why do you need a battery? For what? Huh? What do you think we need the battery for? If the ammeter, Tim, you got a question? You got a question?
No,
Yeah. So if you want to measure the amperage, we have the power in it, so why do we need the battery here? For what? And voltage, we're just completing the circuit. What is the battery for? Yes. This is Ohm's law in action. So the battery, it's a very small battery, it will send small voltage to measure resistances. And again, make sure you understand the range. When you buy a multimeter, understand what range you need. And that's why again, why is it expensive? Some ranges, most ranges for handheld multimeter is between 0 and 600 volts, which is plenty than enough for us. For other stuff, probably you need more than that. There is a special voltmeter we buy for 10,000 volts, this transformer. Question?
How much does that mean?
This goes, it's very generic, so it comes from many companies. It's around like 20 to 40 bucks depending on the company who makes it. But again, I don't believe if you drop this multiple times that's going to work.
Yeah.
But it's good for our intended purposes. If you go with Fluke and Klein are very reliable meters, and most professional will use Klein or Fluke. This goes around depending on the options again. Guys,
They should get us a deal through the school.
huh?
They should get us a deal somehow through the school. If you wanna buy it.
There is a Granger scholarship that opens in January. That will give you 1,500 worth of tools
Nice.
if you apply for it. And it's usually for the 2-year students. So that's an incentive for you to go on the 2 years.
Is it worth it? Like, if you do that, like, you just, where do you go, like, you know, put it up?
I will send out the applications, and you apply online. So that's it's a good scholarship. This one is out of battery, but what is the range? This goes around like 170, depending on the options. And if you see here, there's a lot of options and a lot of things you can measure. One thing I want you to know is looking at the terminals here. Some meters have 3 terminals, one for DC and one for AC. So if you're measuring DC and you put it in the wrong socket, probably you burn your multimeter. This one does not care. It's auto ranging, and it's also it will not be affected if you put it in DC or AC.
What's that, a couple $100 for that one?
Huh?
Probably a couple $100.
Yeah. But again, it's very sturdy, has warranty, and the calibration takes longer period of time. So, again, for our basic electrical circuit, we always going to measure ohms, amperage, and volts. One more thing we might need to measure is microfarads or farads, and those are the units for what? Capacitors. We'll spend a whole chapter talking about capacitors. We talked about capacitors in the first week, and we said capacitors are kind of a battery that hold a charge. It does not give you continuous flow, but it will hold electric charge. And that is very important in our circuit. Usually you find it in motors, and you find it in little circuit boards. If you look at your phone charger, the very small phone charger, it has a capacitor in it, and that will help it change AC to DC. So that's what we need to measure. They have either volt or ohm multimeter, which is this one. What is the difference between those two? Yeah. So if you don't have the clamp on, you cannot measure amperage. If you look here though, you'll see something at the bottom. I'll show you the document camera. Okay, let's look at that a little bit. Most of this marking are universal. What is that? What do you think that is? It looks like a wave, right? So it's gonna make a noise. So what does it measure? Continuity. What about this one? Ohms. What is this little thing here? No, this is what we talked about. This is for capacitors. We give you microfarads. And this here is something called diode. I don't think we're gonna have to deal with it, but if you go into electronics, you need to know what's a diode. What do you think a diode is? No, LED is light emitting diode. So as Tim was saying, diode is what?
No, that's current flow one
Yeah.
direction.
It's a check valve for electricity. And why do we need that? Because if I want to change AC to DC, I need some kind of valve that only will take the positive charge. So I'll put a diode in there, so it will go only in one direction and not back. We'll talk about it a little bit, but not too much. If you look here, what does that say? You know this little symbol that we talked about last week? Micro? Looks kind of not clear. It looks like something like that. It's a symbol for micro. And that's a microamp. So it has to be microamp, 1 part of a million of an amp for this thing to measure amperage. And it does not use clamp on. How does it do it? Basically, you put your probes in series with the circuit, and it will measure the amperage going through it. If it's more than, if it's a milliamp, probably can give you an error. It will just shut off and it not work. What else do we have? What is this, these two here? Volts? What about the line here? DC? And this one is AC, this clearly line. What about this here? HZ.
Hertz,
Hertz, what does that mean?
like the frequency.
Frequency, excellent. So frequency, why do we need to know the frequency? If you are going to install microprocessor, we'll have one here. Yeah. So you will hook up one of these controller here next semester, and these are very expensive and very accurate and very sensitive. This is around like $3,000 when it first came out. Yeah, and
It looked like it did.
it looks complicated, but it's you will understand how it works little by little. But they are very frequency sensitive. What is the frequency in the United States usually? 60 hertz. I wish this thing works so I can show you, but we'll do it again. So, and why do we check that? because most equipment are rated into certain frequencies. So what is the frequency, just to be quick? You see the cycles here? It's how many times go up and down in 1 second. We want to go 60 times up and down in 1 second. If it goes less than 55, probably it's not going to understand what's going on. It's going to confuse the circuit, and it's not going to work. So this is the only time where we can measure frequency, and sometimes frequency can be interrupted. So when in doubt, if you're working with microprocessor, probably they'll tell you to check the frequency. What about this one? Temperature. How does this thing measure temperature? We talked about slightly the first week when we talked about.
Measure resistance in the wire as
Yeah.
it changes.
So if we look at this wire, it's called a thermocouple. Remember when we said we can generate electricity using two dissimilar metals? Remember that? Vaguely, a little bit? We had a thermal pot and we said you can heat two dissimilar metals and generate electricity. If you look closely at this little tip, there are two wires here connected together, and this is and welded together, spot welded. So what happens is this little tip will be heated and it will generate some microvolt. And this multimeter is sensitive enough that it will measure this microvolt. This probably does not have this option because it's not as accurate as this one. So if I plug this in here and try to heat it, I'm going to put it in resistance, actually in volts DC. And I heat this up, it's not going to measure anything. See, I got something. I'm holding it to heat it up, and it's 0.3. This multimeter here will translate that 0.3 into temperature. It will give you what is the temperature. Probably going to be 78 or 90. So see, it's generating voltage. Does anybody have a lighter? You heat this up, you'll see it going up. We'll do it again in the lab. So this is another way where you can have splurge a little bit in a multimeter that can give you also temperature reading. So you can do that and heat it up a little bit. Okay? I think we're out of time, but next class I will talk more about multimeters. And if you have your own, please bring it with you so you can try to translate what we say in the class into equipment you use. Here, thank you.
I was trying to tell you,